All righty. Hello, everyone, and greetings from, I'm actually in Cadiz, Spain right now, which is the oldest continually inhabited city in the entire continent of Europe. So thanks for having me. I'm really honored to be able to speak at your conference right now, Stewarding Our Water Futures. And we're going to talk about a variety of practices and perspectives that would move us from water scarcity to water abundance. So, let's see. All right. So my name is Andrew Millison, and I'm the founder of the Oregon State University Permaculture Design. And I've been with Oregon State University since 2009, and I've been developing an online permaculture program there since that time. And through that, I do a lot of educational media development. And I have a YouTube channel that I publish a lot of the work that we develop on YouTube. And it affords me the opportunity to travel around the world and see a lot of really fascinating water projects. So I'm going to share some of those things with you. But first, I want to talk a little bit about permaculture. So I imagine that not all of you are aware about what permaculture is. Some of you may know, but permaculture is a design science that really is based on pattern observation, based on looking at the patterns, the flows, the forces of nature, and actually mimicking our own designs after the patterns that we find in nature. So here you can see the vascular system of a leaf, right? And think for a minute about some of the other patterns that this leaf actually looks like. I mean, we see the veins in our own bodies, right? And the ways that the vascular system branches. We see the way that a watershed moves water throughout a drainage basin, right? So we see these similar patterns over and over again. And so in permaculture, we're like, how can we actually recognize and then use these patterns in a beneficial way for designing human settlements and all the things that people need? Now, I'm going to share with you a little bit of a secret here. And I have discovered the fundamental flaw of human civilization, right? And in my opinion, the fundamental flaw of, I'd say, Western civilization is that we have superimposed a grid, right? That we pretty much made up a grid of property boundaries, like you can see here in red, and we've superimposed this over a non-gridded landscape because nature has its own patterns of water flow, the branch drainages of the watershed, the drainage basin. And these artificial lines, they create land management units that don't correspond to water flow. And this has had an exceptionally damaging effect on how water's managed, soils, groundwater, how we just perceive nature in general in this fragmented way, right? And so a lot of the work of a permaculture designer or a regenerative water designer is trying to mitigate this fundamental flaw. Places like San Francisco, for example, it's very stark, right? Because it's a hilly city, yet you can see that the grid of roads, of streets, has been plopped down over this very non-gridded landscape. And so in this case, all of the roads become the new drainage ways. And the roads end up actually dehydrating the landscape in as efficient a manner as it can be dehydrated. And so a lot of our development, especially when we're developing on arbitrary grid lines, the roadways, the transit ways end up becoming dehydrating features, okay? But I'm here to talk about the watershed perspective. Because if we are going to actually design systems, design agriculture, design cities, design suburbs and villages and campuses and everything that are harmonious with water flow, then we need to look at the land in the perspective of watershed. So here we have the great watersheds of the United States. We can see the Mississippi River Basin actually gets cut off there, goes into Canada. That's the largest pink shape that you see there. And then, of course, the Ogallala Aquifer that your conference is about is going to correspond with some of these watershed basins here as well. So this isn't new. People have been planning around watersheds for a very long time. I visited a group called the Sovereign Indigenous Nation of Hawaii on Oahu, the Big Island. We did a short documentary about this group and their work here. And we learned all about the traditional Hawaiian perspective on the watershed, and they call it the ahupua'a. And the ahupua'a, their land management unit is the watershed. From the top of the mountain all the way down to the sea, each drainage basin is its own management unit managed by its own group, right? So when we see political management, when we see political boundaries overlapping with natural boundaries, in my opinion, that's actually the idealized relationship with humans and nature, right? So in the Hawaiian ahupua'a system, there are many different elevational layers, from the cloud forest at the top of the mountain all the way to the fish ponds that we find where the river or the creek meets the ocean, right? And we have this kind of mixture of fresh and brackish water. And what I learned when I went there is that because the political boundaries of the society are corresponding with watershed boundaries, there is a real sense of responsibility to the downstream neighbors, that the highest work of any farmer there is to make sure that they actually return water clean back into the system, because the next farmer downstream is going to use that water. So because they're formed around this watershed, the community has a sense of responsibility. And so I think, as humans, like, we really have a lot to learn from these types of traditional societies that really got it right in their communal water management. So again, this is a map of India here. This is the watersheds of India. I've spent a lot of time in India. I've done a lot of video documentation of some of the really largest and most inspiring projects that I think of on the planet. And so, we can look at any country in the world and look at this watershed map, and we start to really get a picture of what's going on there and how to, in this day and age, how to address the biggest problems that exist out there. So one of the organizations that I've documented there is called the Pani Foundation. And the Pani Foundation is located in Maharashtra, India. And it's actually founded by Bollywood star Amir Khan. And what they are doing is they have created a contest, and the contest is between villages, and the villages compete to see which village can install the most amount of water harvesting structures in a 45-day period. Okay, now, because the guy who founded it is a very big, leading man in Bollywood, he's very connected and he's very wealthy, and he's put up a lot of his own funds as well as found a lot of industry partners. And so there's huge cash prizes for the winning village. And what it looks like literally thousands of people going out there, taking training. They have representatives that take a training, and then thousands of people going out there and communally digging water harvesting structures all along the upper watershed, and then stepping down into the lower watersheds of these villages in order to replenish the water table, basically. And so in the 4 years that they ran the water part of this contest, they had about 8,000 villages that literally saved and regenerated their water tables through this process here. This is a really nice drone shot that gives you a little bit of a sense of some of the different types of structures that they use on these plateaus. You can see these little lines. They've got sort of what they call continuous contour trenches. We might call them on contour swales. They've got these different, they call them compartment bunds. They've got different reservoirs built into the drainages. And so they're doing a full watershed treatment from the top to the bottom in 45 days. And then the monsoons come, and literally in one monsoon season, they are regenerating their entire water table in that basin. So it's a really dramatic and very rapid change. And the reason why this can happen so easily is because the village boundaries are the watershed boundaries, right? These villages are really old. And back to a time long ago when common sense ruled how we govern, right? And so it made sense in this particular topography that the top of the hill was the boundaries of one village, and then you go down and the next basin over was a boundary of the other village. So when a village gets together and they decide that they are going to actually do water harvesting structures on their common land, that common land corresponds with the watershed, and then the water table is just built. It's really magical how that happens. And everybody understands that. So this right here is, you can see me taking a video. This is a diagram. This is in the center of one of the villages that I visited. And in the center of the community, they actually have the watershed map, and they have their design diagrammed out there. And there's a key that's all written in Hindi there. And so the people, everybody in the village, from the oldest person to the smallest child, sees this mural every day. And this is, there is a communal understanding of the watershed. And this is the place that I wish we could get to everywhere, because this is how we actually fix the water problems that are so persistent, or one way at least, okay? And so this model right here, this is actually one of the training models from the Pani Foundation. So they throw this big training, and they get representatives from each village. And this is their watershed model to demonstrate integrated watershed management, right? So how do we get it done? How do we get it done here in the US? Actually, here, I'm in Spain right now, but you guys are in Texas. So let's look at some examples from the United States here. This is Village Homes in Davis, California. Very known development in the permaculture world and other people who look to, ecological housing developments. And the wonderful thing about Village Homes is, okay, it's not like these villages I showed you in India where they're actually using a whole, taking a whole watershed and designing it, but they are taking all of the water that falls on site and they are absorbing it into the landscape. So you see these rows of houses. These rows of houses are running east to west. You can see the solar panels and all the roofs. Those are going to be the south side of the roofs. And so all of the development, first off, aside from water, all of these houses are elongated east to west. So they're all designed for passive solar heating, passive solar lighting, which will reduce the energy by half of a house that is poorly oriented. And then in between each of these rows of houses, they alternate. So in between one, you can see there's a cul-de-sac basically. And then the next space between the houses, there's a giant bioswale. So all the water from this development, all of the roadways, all of the roofs are absorbed into bioswales, which we find every other row of houses. And those bioswales are planted densely with all different types of food plants and lots of trees. It's incredible. I wandered around there, and literally you can just walk down the path and you open your mouth and close your eyes and food just falls in your face, right? There's just grapes and peaches and citrus. I mean, it's a Central Valley, so like everything grows there. It's really incredible. This is a diagram of that community there, the whole site right here. And again, there's a satellite image on the left. On the right, look and see how the between the rows of houses, you can see those cul-de-sacs, and then between the cul-de-sacs, you can see this greenway, right? And so, I mean, this is an incredibly desirable place to live. And actually, this is the sad part of the story. They never replicated this in Davis again, because the main opponents to having more developments like this, right? Everybody take a guess for a second. Look at your neighbor. Who would oppose such a thing? Tell me. Who would oppose such a thing? It was the realtors. The realtors hated this. And the reason the realtors didn't like it is because nobody moved. Nobody wanted to move because they lived in such a beautiful, abundant, luscious community. They had low costs because of the passive solar design. They were surrounded by food. It was wonderful, right? So anyway, here's some more pictures of that there. Meandering pathways going through blooming fruit trees. And then you can see a little bit on the right-hand side, some of the water control structures there, bringing water from the roadways, the roofs into, on the lower right, you can see a full bioswale. And it's not only drought resilient because they built this underground water table, it's also flood resistant. So when it was flooding everywhere around this community, it didn't flood here because the bioswales, they were, creating a place for that water to settle. And also all of the vegetation, all of the trees created really incredible drainage profile in the soil. So it just sucked up the water into this giant sponge of a community. So a really excellent, excellent example. And also, here's one more picture. They had a lot of urban agriculture. Oh, on the upper left, that's Davis, California. But I have some other pictures as we go along of just urban agriculture. And just even in an urban landscape, the capacity of gardens, anywhere where we're building carbon in the soil, we're creating a lot of organic matter, it becomes like a sponge. So just having healthy soil is another form of water management. It's the easiest form of water management, really. And, that leads us to the types of developments that would foster rainwater harvesting, that would foster the kind of soil that is going to sponge, right? So one word that has been coined recently is the concept of an agrihood. An agrihood's like an agricultural neighborhood, right? So when we create green spaces, when we create organic rich soil in urban areas, in neighborhoods, then we naturally start to manage water. And then, of course, that can be added to things like rainwater harvesting tanks and bioswales and all of those good things that we love so much. So here's another example of a development that's built around water management. And this is outside of Tucson, Arizona. This is the Milagro co-housing community. And one of my permaculture teacher, Brad Lancaster, he was one of the main consultants, designers on the water system here. So for anybody who knows about what co-housing is, it's basically you're taking all of the structures, the houses, and instead of spreading them out across the landscape and everybody has their own driveway, everybody has their own garage, everybody has, you have to have all this roadway to get cars to everybody's front door, basically. It's like, hey, let's cluster the cars in one area, parking lot, and then let's make the houses, let's cluster all the houses together and have a pedestrian movement through there. Okay, so this is a 40-acre parcel. And instead of having the houses spread across the landscape, they kept the landscape open so everybody has access to a park right out their back door. And the housing is clustered in a sort of a communal fashion. And so this is the interior of that housing cluster. And this is before they did the planting. So this is right when were still doing the construction. And this is just a shot that really shows how, they have raised pathways. They have sunken basins, and all of the roofs of all the houses, all of the runoff is directed into the center of the community, into these basins, and each basin overflows one to the next, right? And so from a satellite viewpoint here, you can see I've outlined the center of the community in blue, that little blue line. So that shows where the concentration of water is happening. Here you can also see, like off to the right, you can see the parking area with covered parking, how that's separate from the housing. Okay. And then here are all of the structures. Now, all of these structures also, the entire pattern of how the houses are placed here is passive solar design. It's not straight east to west. It's the whole thing is like an elongated structure, with if you add up all the buildings oriented to the southeast, which is a nice orientation in the desert landscape. And then the wastewater from the community also, that's, they're getting their water supply from a well for their fresh water. The water is being used interior in all these houses, and then it's actually going through a treatment facility, like a wetland, constructed wetlands treatment, and then any excess water that makes it through the wetland is actually then pumped back up and used for supplemental irrigation, for even more irrigation. So they don't have to use any fresh water for irrigation. And this is what it looks like in there. I mean, these trees have just spread out, these desert trees, along with all types of different cultivated plants, and created a shady oasis in the middle of the desert, right outside everybody's front door, right? And basically, they have mimicked the pattern of a sheltered canyon oasis, right? So, because if you think about it, where's the nicest place to go in the desert? It is a sheltered canyon, right? And so with the placement of the houses, so the houses are like the canyon walls, and all the water's concentrated in the center of the community. So the center of the community becomes like the stream in the middle of the canyon. And then, of course, that microclimate means that all this different luscious vegetation grows up there. And that's the nicest place that you want to be in the desert. Okay. So let's look at some other examples and some different climates of places where people have created models that can really guide us for water harvesting. So this is Vine Street here in Seattle. And Seattle, for anybody that's been to Seattle, it's a very hilly city. It's right there in the Puget Sound. There's a lot of water around there, yet because of the intensive paving, the hardscape over the city, the streets, the buildings, there has really been a desertification, a groundwater desertification has been created because water is just running off. And not only is it not soaking in and running off, it's running into the Puget Sound, where we have orcas. It's like critical habitat for whales and all types of different species. So this is a wonderful project and the thing I like about this is that they integrated this kind of artistic design into it. And I'll show you there's some other areas in some later slides here. And so the runoff is taken from these roads, from these roofs, and it is going into this series of overflowing little terraced basins, one to the next. It's soaking in, it's supporting tree cover, it's supporting shrubs, it's supporting different herbaceous perennials, and is building the groundwater instead of taking dirty water runoff from roads and putting it directly into an important water body. And this is another part of it. This is actually the top of the system. And I just love this. It's called the beckoning cistern, right? So the cistern, it's like a hand. You can see the fingers. So the hand is beckoning water. And then the cistern, they put it like off kilter. It's very an interesting form there. And you can see in the upper right, you can see the downspout from the adjacent building is going right into the cistern. And then the spillway right there, you can see the water is actually spilling over the spillway. It is this nice little arc. So they have the water falling out in the open. It's spilling into one little terrace, which then you can see if you look closely, each little terrace is spilling to this other round pool and to the next round pool. And they're really creating an artfulness out of water management. And this stuff has to be interesting. It has to be exciting, because people like you are excited by sustainable water management. People like me are excited by sustainable water management. But in order for the attention and energy that is needed to really fix our problems, we need to have people that are inspired, that think that water management is actually cool and something that is beautiful, right? So I just love this example because they just they were just full on intent with trying to make it beautiful here. So I want to talk a little bit more about Brad Lancaster. Brad Lancaster is the author of Rainwater Harvesting for Drylands and Beyond, volumes 1 and 2. And many of you may have heard of him. He was one of my teachers, one of the teachers of my permaculture design course back in 1996. So I've been following his work now for 28 years. And it's so simple and so brilliant. So basically, he pioneered the curb cut in Tucson, Arizona. He didn't ask permission. He went out there and he basically took a concrete saw, he cut some curbs, excavated some basins, and planted an assemblage of native plants, of mesquite trees, Palo Verde trees, trees that would, because they're native, they would grow even in the open desert, but native plants like this, if they just have a little bit of extra water, they will grow really prolifically. So every time you get a monsoon season here, the water falls on the roadway. It is then running down the gutter and it hits these open curb cuts. It infiltrates into these basins and then meanwhile feeds these trees, right? So the trees, as they've grown up, they have shown they literally cool aside compared to the open blacktop. The area underneath the trees is easily 20 degrees Fahrenheit cooler than the open blacktop. So, I mean, it's dramatic cooling. Brad talks about it as planting air conditioners, right? And so I really like to see it as the marriage of street trees and stormwater runoff. We should not be doing infiltration of stormwater without also creating perennial vegetation. And trees, and like especially a place like Tucson, Arizona, that's incredibly hot, of course, the cooling effect, the habitat effect, the food, these mesquite trees, they harvest them, the pods for making flour. The blooms are incredible for honey production, honeybees, mesquite honey is wonderful. And it just makes a really pleasant environment that creates a lot of, there's like quail showed up there all of a sudden. It's a cacophony of birds in this area because of the diversity of plants that are all fed by stormwater runoff. So stormwater runoff is like a habitat accelerator. And so, yeah, here's a nice example. This is from a study they did in Australia here. And they took a temperature of basically the ground surface. So the ground surface of blacktop in this area, this is Sydney, Australia, was 142 degrees Fahrenheit. This is like fry an egg on the blacktop hot. And then the ground surface underneath these shade trees here was 94 degrees Fahrenheit, right? So this is the effect of water. I mean, I've talked a little bit about effect of water harvesting, building groundwater tables. It goes both directions. We're building groundwater tables and we're building shade and resilience to the heat island effect, right? That's, the blacktop that we've paved the cities with is not only creating a situation where water's not infiltrating, it's creating a place where heat is being generated really excessively, which has so many damaging effects on people's health and just the natural environment. So let's look at an extreme example right here. This is Saudi Arabia. And this is an area, this is not too far from Mecca. And this is an area that receives between 0 and 1.5 inches of rainfall per year. Now, the government of Saudi Arabia, they decided that they wanted to settle the nomadic Bedouin people. I don't know why. And I don't necessarily think that that's a wonderful thing, but that's what they were doing. And so the problem that they were trying to solve was, how do we create a place-based livelihood? Because when people are nomadic, they have herds of goats, for example, they're moving place to place and they're not exhausting one ecosystem. As soon as you take nomadic people and they're no longer nomadic, then they just devastate the ecosystem very quickly because everything becomes overgrazed in such a brittle environment. So the government of Saudi Arabia worked with some people, a guy, Neil Spackman, and Jeff Lawton was part of this, another permaculture pioneer. And they developed a series of water collection swales. You can see these lines of green that are collecting the scant runoff that occurs in maybe one or possibly two rainfall events per year on these rocky hills, right? So in the very short period of time, there is a great deal of water flowing down this landscape. And so they basically created embankments and they trialed trees from dryland environments from all over the planet to see what would survive on rainfall alone. So they started out by doing irrigation, drip irrigation. They only were taking out from these deep wells they had the volume that they were putting back in through infiltration. So they were making sure that they were maintaining their water budget. And then they trialed all these different species, and then they shut the water off. Once they got everything established, they shut the water off. And then it didn't rain for a year and a half. And things were dying. And Neil Spackman said, he said the guys on site were begging him to turn the water back on. He was like, we have to see what can actually make it. And at the end, after it rained again, after a year and a half and it rained, they came up with 4 different species that could survive with no supplemental irrigation. They could survive on their own in this harsh climate. And so now they've developed a pattern of vegetation that could be married with water harvesting structures that could revegetate the entire west coast of Saudi Arabia. So, I mean, through that experiment, they basically came up with a pattern that they could replicate over a large area that would then have climatic repercussions down the line with more trees there. So, you know, if it can be done here, if you can actually create a regenerative water system that supports permanent vegetation, economically viable trees that they could actually use for creating like high value oils was one of the products, where can't you do it? Right. So, you know, it's really, really an inspiring project, because anywhere, pretty much anywhere in the world practically is wetter than this. So, you know, back to permaculture for a second, water management is really the bones of any permaculture system. So we start with designing the water, and then all the other pieces go on top there. And that's why I'm really focused on water with my work. This is a picture of the New Forest Farm. This is in Viola, Wisconsin. Mark Shepard, he's a well-known farmer, permaculture activist, designer here. And this farm right here, the rows are oriented based on a thing called the keyline design system, which was developed in Australia in the 1950s. And basically, it's a system of orientation. It's like a geometry where you orient the rows of your farm system where they slope from the valley form out to the ridge form. So it's like a pattern that just by its orientation, it rehydrates the driest parts of the watershed, the ridges. So anyway, you know, when we're looking at designing systems, when we're looking at vegetation, we're looking at farms, we're looking at cities, we're looking at towns, neighborhoods, developments, all these things. First, we're looking at water, and then we're building on top of that. And, you know, that's what we talk about in a permaculture design course, right? So, you know, we have Oregon State University, we have permaculture design courses that we teach online for both for-credit and non-credit students. And if you want to see more, I have, like I said, I've spent the last number of years traveling many places in the world and documenting some of the most inspiring permaculture and water management stories out there in the world. That's what I'm doing right now in Spain. I'll tell you for a minute. We came to see the most progressive regenerative seawater agriculture project, where people are actually, this is like the opposite end of the spectrum, where people are actually turning salt marshes here into productive saltwater-based agricultural systems. And I spent the last 2 days filming in the delta of the Guadalquivir River at these really, really large scale halophyte, which are plants that run on saltwater, halophyte agriculture projects, that polycultures. Is really, really fascinating. So anyway, that's kind of my jam. Checking these things out, and you can see lots more videos here on YouTube. And we've got some time, so I'm going to open up for questions. I am going to stop sharing.
Hey, Andrew, thank you for your talk. I don't know if you've actually visited or done any research on the high plains, but I mean, we do have some interesting, unique features. We've been talking all about playas, and we have sort of like a semi-arid grassland system. So I don't know. I guess I'm wondering, I think something that we grapple with a little bit here is you have sort of nativists who say this is all grassland and there were no trees, but then you get into an human civilization, you say you want trees, because I just think personally there's sort of a human need for trees. And I don't know, I was wondering if you've like run into that anywhere else, if you've ever visited other nomadic places and how they think about being settled.
Yeah, well, I mean, there's certainly like the Great Plains are certainly historically a climax community that was a grassland community. Of course, they've lost a lot of soil, and they are only at a fraction of the greatness that when we hear the historic like the images of the first people to document the grasslands and how they were riding on the horses and the grasses were the horses were sort of popping up the top of the grasses. So I feel like whenever we have human settlements, right, where we really have a concentration of water, certainly those places we're going to want trees. Like nobody, the plains are windy, so nobody wants to be without shelter. And then of course, anytime that we have human settlement, we have a concentration of wastewater also. And so so I definitely think that trees around human settlements in grasslands are are appropriate. Now, do we actually like is there a place for bringing in like silvopasture agroforestry system into plains ecosystems? I mean, I don't really know. Like I am not a native purist by any means. My response to people who feel like we should only plant native vegetation is like, what did you eat for breakfast this morning? Right? Because unless, like, for where I live in the Willamette Valley, unless you ate camas bulbs, acorn meal, squirrel and venison, then you probably are displacing a native ecosystem somewhere else, right? So, the permaculture perspective is like, it's better to have your food around you and have a diversity of food plants. Of course, native plants are included in that. But as far as like creating, well, okay, the other place that we have really permanently changed the landscape is in road placement, like I was talking before. So anytime we have a roadway, again, we have a concentration of water that was never previously there. So as soon as we put roadways on a plain type of landscape, we're changing the distribution of water. So I would say that also might be another place where you're like, okay, we have more water here now. Should we up the complexity of this ecosystem to trees? So I would start there, which is like mitigating the human development pieces, like structures, roadways, and I'd probably integrate trees in those systems, for sure, if I was designing something. And I am interested in coming in, like talking to people in the plains to see what some of the solutions from there have been. Did that answer your question?
So thank you for your presentation, Andrew. In the instances where the realtors were fighting the development of this agrihood, um, do you know how any of these cities were able to counter that? Or how do you get investors involved in something that's very novel, where everybody wants their little white picket fence, everybody wants their own backyard? Are you able to get investors to really get on board with this, like the agrihoods and developing a lot more sustainable living arrangements?
Yeah. I mean, first off, the case of Davis, California is actually sad because they never did build another one. So they tried and they never actually could. So, it's a little bit of a tragic tale in a sense, and it's not like doesn't provide a great answer for your question, but it's just the truth. Um, I I feel like the the developers will go with the whims of the consumer. And there are a lot of really saleable features in these types of developments. Um, I mean, one thing is just like the energy savings from good passive solar design and good construction methods, right? The safety of having, things built in a way that encourages social interaction. Um, Increasingly so. I mean, I guess I am optimistic in a way about like what I see people wanting and what I see people turning away from. I think that as the stresses of the world get more intense, I feel like there's a lot of angles, sort of sales angles in these types of developments where this is you have resilience, right? Like you have food growing around you. You have a self-reliant water supply, for instance, if you're doing water catchment or you're doing groundwater replenishment. I think in a way, as the world gets crazier in a sense, we have more intense climate extremes, and we have more, where people are more like kind of stressed out on a fundamental level, where they're scared for just the general future. Um, these solutions are really like calming for people when you're like, wouldn't you like to live somewhere that has a water self-reliance, that has food planted all around, that is set up in a way that's conducive to community, that is, I mean, I feel like people are more apt to move on their own self-interest as opposed to like, I want to do the right thing. I feel like the personal benefits of having an ecologically designed community, without even talking about the environmental benefits, but just like the benefits to the individual, I feel like that's enough of a selling point. And so, I mean, I'm optimistic, I guess, because I mean, maybe I'm just in a bubble now because the people that I tend to be in contact with are into this stuff. But I mean, I'm being contacted by all sorts of people around the world, people with resources, people that want to do big projects. Like the trend of the world right now, look at, for instance, that was a Neom, the big line city that they're building in Saudi Arabia, right? I don't like that design. I don't think it's an ecological design, but that's it's just kind of ironic because like that's what people are going towards, things that are not normal. I guess that's my point with that. People are going towards things that are not the same kind of cookie cutter development that we've had up till now. So I think that people are changing, and I think the opening is there. And I think that developers, when they see that this is actually something that would make people happier, that's like the leverage point, in my opinion, for how developers could be moved to do something that's more progressive.
Thank you, Andrew. I think it is time to move on to the next one at this point. But thank you for joining us. Wonderful presentation.
Awesome. Thank you all. I hope you have a wonderful rest of your conference. And it was really great talking to you. Thanks so much.